Cambridge International GCSE Chemistry, Paper 2 Prep, Exam Tip 2. Paper 2 questions have a focus on kinetic theory, explanations of states of matter, state changes, interpretations of heating curves and cooling curves. They're most often found as questions 1, 2, or 3. So looking at the states of matter, which of course are solid, liquid and gas, questions often focus on the arrangement of particles in the 3 states. So in a solid, we say that the particles are ordered in an ordered arrangement with the particles, all particles touching. In the liquid, we have a random arrangement of particles still touching. The process of going solid to liquid is of course melting, and the reverse process is freezing. Now, if we look at the change from liquid to gas, in a gas the particles have a random arrangement, but they are far apart. And we obviously call the process liquid to gas boiling and gas to liquid condensing. But there's also the term evaporate. So boiling is a special case of evaporation. Evaporation is also a change from liquid to gas. It occurs at the surface of a liquid. Questions also focus on the motions of the particles in the 3 states, or the differences between the motions, and the strength of the attractions between the particles. So if we look at a solid, then there are strong attractions between the particles, and the particles vibrate around a fixed point. In a liquid, the attractions between the particles are weaker, and there is some freedom of movement. In a gas, there are very weak attractions between the particles, and the movement of those particles is much quicker. Another type of question concerns the state of a particular substance at a particular temperature, and that of course depends on its melting and boiling point. So for water, you are expected to recall the melting point as 0 and 100 for the boiling point. But to answer a question such as, what is the state of water at 45 degrees Celsius? Well, then I would advise drawing a number line. We know that at 100 degrees Celsius, that's the boiling point, so above that it's a gas. We know that the melting point is 0, so below 0 water is a solid, and therefore between the boiling point and the melting point, water is a liquid. So at 45, we simply say, where is 45 on this number line? So if this is 45, then water would be in the section of liquid. And if we had, for instance, another example, -5, we just position -5 on the number line, our water would be a solid. So let's quickly revise heating and cooling curves. So let's imagine we're heating stearic acid. We're measuring the temperature and time, and we plot our temperature against time on 2 axes. We find that the heating curve produces plateau. Now those plateaus correspond to state change. So as we heat stearic acid as a solid, it becomes a liquid. We get a plateau, a point at which the temperature remains constant for a period of time. That corresponds, the lower plateau corresponds to the melting point. If we continue to heat the liquid between the melting point and the boiling point, obviously we have a liquid. So if we continue to heat the liquid, the temperature rises until a new plateau is reached, at which stearic acid changes from liquid to gas. In other words, it boils. And again, we get a constant temperature for a period of time. So the higher plateau corresponds to the boiling point. The lower plateau corresponds to the melting point. Below the lower melting point, we have stearic acid as a solid. But above the boiling point, we have stearic acid as a gas. And between the boiling and melting point, we have a liquid. Now, why is it that the temperature remains constant during state change? Well, energy is used to break attractive forces between the particles. So in a solid, there are strong attractive forces. In a liquid, they are weaker. Well, that process of weakening occurs on melting. In a liquid, there are attractive forces between particles. In a gas, there are very few. So at boiling, those attractive forces are broken, allowing the particles to move much further apart and form the gas. So, exam answer, energy is used to break attractive forces in state change. Let's look at a cooling curve. So the temperature is dropping with time. Let's stick with water. So hot steam is cooled and its temperature monitored over time. We find that the plot of temperature change against time provides us with two plateaux, which is where we locate the state changes. So at the upper plateau, which we call the boiling point, we have a gas turning into a liquid, so that's condensation. Above the boiling point, we have gas. Below the boiling point, we have liquid. So this is, as it's cooling, it's condensing. The lower plateau corresponds to the melting point. So again, the liquid, as it's cooled, turns into a solid. So the plateau temperatures correspond to boiling points and melting points. That is, at the melting point, freezing and melting occurs depending on the direction of change. At the boiling point, condensing and boiling, or evaporation, condensing and boiling occurs depending on the direction of change. Above the boiling point, we have a gas. Below the freezing point, we have a solid. In between, we have a liquid. So my clear advice is that you need to practice past paper 2. Try to find questions on kinetic theory, question 1, question 2, question 3, or they appear towards the end, question 39. If you haven't been given papers by your teachers, no problem, go to Physics and Maths Tutor website. You'll find Cambridge International GCSE questions are available there. If you found this quick review helpful, please recommend it to a friend. Please like, and if you feel able, please subscribe.